Opo, ma'am, meron po.
Pero tungkol dito naman or yung previous lecture natin?
Tungkol po doon.
Okay, sige. So, gaano katagal usually yung exams nyo?
Bale po, every week po, ma'am, nag-quiz po kami.
Sige, I'll try na lang to see if kaya kitang tulungan during those times, no? Pero hindi ko kasi siya mapapromise. Pero
Okay po.
let's try this na lang para just in case tungkol dito or medyo similar yung yung magiging question is ma-familiarize tayo dun sa steps niya. Kasi ito medyo madugo tong combined axial bending. Tinitignan ko yung sinend sa inyo na na handout. Parang nakakalula nga siya pag pag student ka tignan. Okay, so let's start dito with combined axial and bending. We have all these formulas. So for flexure and compression, ito siya. So PR over PC, yun yung required sa available. Pag greater than 0.2 ang gagamitin natin, ito. PR over PC plus 8 over 9, MRX over MCX, R is the required, C is the available, RY over CY. So yung X and Y natin is for the axis. Always, yung X natin is the stronger one kung asan yung major axis natin, and yung Y yung minor. So if chinek natin yung PR over PC, which is less than 0.2 naman siya, ang gagamitin natin, PR over 2PC, MRX over CX plus MRY over CI, which is supposed to be less than 1.0. Okay. Pag na greater than 1.0 to, kailangan nating mag-redesign. Kasi ibig sabihin, masyado na siyang malaki, hindi niya kakayanin yung load. Okay. So, next we have for tension. So, pag tension naman, halos same na same ang gagamitin natin. Pero instead of compressive, dito, the flexural strength, ang gagamitin natin is the tensile strength. Ayan. So, ito. Ang difference na lang is this one. PR is now your tensile strength. Your PC is your tensile strength also na ginamitan natin ng multiplier. So this is your nominal times 0.9. For doubly symmetric, isa-solve natin yung CB. Ito siya pag tension. And your PEY, that is pi squared ELY all over L squared. So, ang dami. Again, what we do, we write that down. Let's familiarize with the formula. And then, subukan natin siyang i-apply. Okay. So, next, we have your doubly symmetric single axis. So, for doubly symmetric, ito pag yung KL mo sa z-axis is less than your KL sa Y. So, meron ito lang, madadagdagan lang yung ating mga formulas wherein you have PR over PCO, that is your compressive, plus MRMCX squared less than or equal to 1.0 again. And then these are more possible formulas that we might use depende sa hinahanap sa problems natin. And then here is where we're getting the value of Fy, Fu, and the thickness. Ayan. So, pag sinabing A36 steel, kaya tayo gumagamit ng Fy equal to 36 kasi equal siya sa 36 KSI. Yung katulad nung kanina, pag sinabing grade 60, katulad nito, ayan, automatic 50, grade 50, 50 KSI yung Fy natin. So, I'm going to give you a copy of this PowerPoint para pag hindi mo makita sa notes mo, at least meron tayong extra copy within the group chat. Ayan. Okay. And then next, you also have, pag i-convert mo naman to, let's remember na lang na 1 KSI is equivalent to 6.895 MPa para makuha natin yung megapascal. So, say kailangan mo ng 836 in megapascal. So, that would be 36 here. Yan. 36 times the multiplier of 6.895 MPa. And let's move forward. This one is different values of K. Ayan. So, ito pag fix, ibig sabihin parehong fix ends. So, yung K natin dito is 0.5. Pag meron tayong hinge and fix, so fix at one end at hinge sa kabila, 0.7 ang gagamitin natin K. Pag fixed with translation, ito fixed siya along the moment pero lumilipat-lipat siya sa side. 1.0 ang value. If we have dalawang hinge, parang simply supported, the value of K natin dito is 1.0. Pag fixed tapos free, parang mga flagpole, ganyan. So, ang K natin dyan is 2.0. And if you have translated and hinge, 2.0 also. So you don't have to memorize this as long as it's available when you need it and you remember them. These are the theoretical K values. So magamit natin ito mamaya. We also have the lateral torsion buckling. So ito yung deformation ng beam due to the applied load. So pag binalikan mo to, itong layo na to is our deformation. So kung lumipat siya, ayan. So kung nag-buckle siya dyan, lumipat siya dyan, nag-buckle siya dito, nag-translate siya doon, those are our deformations. And for every deformation, nagkakaroon tayo ng lateral torsion or buckling. So to solve for that, we have LR is equal to 1.95 R times E over 0.7 Fy times the square root of JC all over SXHO times the square root of 1 plus the square root of 1.676 times 0.6 Fy SXHO over EJC squared. So this looks like it's really long and it's really hard. Pero kailangan lang nating tandaan yung formula kasi mamaya direct substitution naman siya. All of this are almost given. Itong mga Fy natin, E natin, modulus of elasticity yan. What else? RS, that's always almost given. And we also have CB. So CB is just a modification factor. Kumbaga ito yung nagiging multiplier natin mamaya pag kinukuha natin yung lateral torsional buckling. So, ayan. So, kailangan natin to if ever yung mga ginagamit naman na natin is non-uniform. So, hindi na siya pare-pareho from end to end. Halimbawa, from one end, 0 yung moment, 0 yung uniformly distributed load natin. And then at the other end, biglang naging 30. So triangular loading na yun. Kaya tayo gumagamit ng CB para makonsider natin yung bawat position of the load. So you have your Mmax, MA, MB, and MC. Next, we also have your moment capacity. Ayan. So for these cases, the unbraced length, LR and LP, the design moment strength will fall approximately on a straight line between Mn is equal to phi Fyz at LP and phi Sx Fy minus Fr at LR. So this is a lot, pero bear with me. Maintindihan din natin ito mamaya once we have the example. And katulad nito, the moment capacity can be determined by the following expression. So itong CB dito, this one, Yun yung masosolve natin from this equation. Itong equation na to. Ayan, itong CB na to. Okay? So, we also have this design procedure. So, para hindi natin makalimutan, naglagay ako ng step by step para hindi rin tayo malula sa kung gaano kahaba yung magiging process of solving the problem. So, una, check natin yung cross-section classification, kung slender ba siya or non-slender. And then, i-check natin yung slenderness ratio, about the x-axis or the major axis, and then slenderness ratio of the minor axis. Tapos, pipiliin natin kung alin doon, then critical buckling, flexural buckling, and then nominal compressive, and then makukuha na natin yung available strength. So, yan yung gagawin natin ngayon. We have 4 examples. So, let's begin. We have example 1, determine the buckling strength of a W12 by 50 column. Its length is 20 feet. For major axis buckling, it is pinned at both ends. So, tandaan natin, pag pinned at both ends, ito, pin connection, ang K natin is 1.0. Okay. So, pinned at both ends. For minor buckling, it is pinned at one end and fixed at the other end. So, pag pinned and fixed, pin dito, fix dito, K natin is 0.7, recommended value is 0.8. Okay? So, yan. Ang hinahanap is, hanapin natin yung buckling strength. Okay. So,
Pwede may tanong lang po, ma'am.
yes.
Ano po malaman mo kung ano yung minor axis sa major axis?
Oh, the minor axis is kung saan tayo usually nag-bend. Meron ba ako example dito? Wala. So, for the minor axis, yun yung axis of least resistance. Wait lang, meron akong picture ata here. Teka, hanapin ko lang. And, wait, di ko siya makita sa notes online ko. Pero I will send later the whole PDF kasi andun nakalagay yung determination of the major and minor.
Okay
Ayan.
po.
Pero usually, ang minor axis natin is along the least resistance kung saan madalas siya mag-fail. The major axis is the greater resistance naman siya. So, parang kung ang ito, I'll try to draw. So, if ito yung ating steel I-beam, nakita ba? Yan.
Opo.
So, we have this axis here and axis there. And most likely, ang bending nito is, wait lang, hindi ko mabend ang drawing. So, most likely ang bending niya is like that. So, that is our I-beam. Yan. So, pag ganyan ng bend, this is your major axis. Kasi, ang nangyayari, bihira nating makita ang I-beam na mag-bend kung saan andun yung flange natin. So, if this is your I-beam at naglagay ka dito ng pressure, bihira na ganyan yung bending niya. Dahil ang nangyayari, nai-stretch yung dalawang flange natin. Ito kasi makapal to eh. Ayan, so pag na-stretch to at na-compress to, yun yung bending along the minor. Ito yung minor natin. Yan. Ito yung major. And mas nagbe-bend along the major axis kasi ito lang, ayan. Ito usually ang common failure. Pag ganito.
Okay po, ma'am.
Yes. And that usually happens for columns. For beams, it would now be based on how the load is distributed. Kasi ang bending naman natin sa beams, pag ganun naman. So, ay, hindi nagbebenta. Ayan. So, pag ganyan yung beam, ganito ang I-beam natin. Your major axis would now be this way. Ayan. Okay. So let's try this. Determine the buckling strength of a W12 by 50 column. Given ng ating elastic modulus, 29,000 KSI. Given na din yung IX natin, 391 inch to the fourth, and yung IY. So this is your inertia along the X and along the Y. Okay. So this is medyo easy. The first thing we do is that we get the KX LX and the KY LY. So this is called your effective length. Kasi hanggang dito lang yung kinoconsider natin na makakatulong when it comes to the buckling of the beam or the column. So kaya natin ginamit yung case kanina. So for the minor axis, that is 1.0. So lalagay natin dito 1.0. So this is the value of your K times your effective length. So since iisa lang yung length natin, 20 feet, that means pareho sila. So Ly is now equal to Lx, which is 20 feet. And then itong feet na to, let's convert that to inches. Kasi lahat ng ano natin dito is in inches, the KSI and the IY. So this is now 20 times in 1 feet, there is 12 inches. Para mag-cancel yung feet dito. Ilan yung KYLY natin?
240 po.
240 inches. Okay. So for KX, ang theoretical value natin is 0.7 times 20 feet. And we also convert that into inches. So over 1 feet.
Bali po 168 po.
168 inches. Okay. And then from there on, ilagay lang natin ito sa ating formula for critical load. So we have critical load. So that is now PCR is equal to pi squared times EI over our effective length. Ito yung LB kanina. So balikan natin yung ating mga formulas. PCR over LB. So ito yun. Axial tension acts with flexure. So you have pi squared EI over LB squared. So ito na yung ginagamit ngayon. So we get that to get the critical load. That is P is equal to pi EI, pi squared EI over LB, where in LB B is now equal to your KL. So your LBX is equal to KXLX, and your LBY is equal to your KYLY. So yung LBX na solve na natin kanina, that is your 168 inch. And your LBY, that is 240 inches. Ayan. So ilagay na natin. So for critical load along the x-axis, this is now pi squared times E. One
29.
Sorry. 29,000 times I natin is along the x 391 over LBX, that is 168. This is for our theoretical values. Ayan. So ano yung value ng PCR or critical?
Ito po, 666,139.
Okay. And we have the critical along the Y. That is now equal to wait. We forgot we have to square this. LB, this is LB squared. Yeah. So ilan to?
Bali po, 3,965.
3,965 chips. Yan.
Point,
Point, may katuloy pa to?
116 lang po.
116. Okay. And now let's get the theoretical buckling strength of along the y-axis naman. So we have now pi squared times E, 229,000, times IY, that is 56.3, all over the effective length, that is now 240 squared. So our critical over Y is equal to ilan?
279.
279.759. 759 kips. Okay, so this is the theoretical values na pwedeng kayanin. Pero dun tayo pupunta sa ating recommended design value kasi it's a lot safer than our theoretical. So let's solve for the recommended. Okay. Palitan natin ang color for the recommended. Yan. So for the recommended, magbabago yung KXLX at KYLY mo. For KY, since yung theoretical na 1.0 at yung recommended na 1.0, hindi nagbabago, hindi na magbabago yung sagot natin dito. Kasi same siya, diba? Ang magbabago sa atin dito is the major axis wherein ang kx na natin is, yan, so let's solve for LB. That is 0.8 times 20 feet times 12. 12 feet over 1 foot para mag-ano. So, ilan ang
192.
192 inches. Okay. And then let's solve for PCR or critical along the x. That is now equal to pi squared times 29,000 times 391 over 192 square.
Bali po, 3,035.
3,035. Point
792 po.
792 kips. Okay. So, this means na ang mangyayari, katulad nung pinag-uusapan natin kanina, we have this, ito. So, ito yung ating column. So, pag naglagay tayo ng force dito, kahit umabot pa tayo ng 3,000 kips, hindi siya magbabakal along the major axis. Pero ang mangyayari, tutumba siya, 200 pa lang, tutumba na siya along the Y. So tutumba siya pag ganito, never na pag ganito. Kasi kailangan mo umabot ng 3,000 para mag-fold siya this way. Pero kailangan mo lang ng 200 para mag-fold siya papunta dito sa side na to. Okay?
Bali po ma'am yung minor axis yung mas maliit na ano.
Oo, yung minor axis yung mas maliit. Ibig sabihin nito, umabot ka pa lang ng 279, magfe-fail na yung column mo along the minor axis. Ayun. So parang ruler, pag inipit mo yung ruler, isa lang lagi yung bend niya. That is your bending along the minor axis. Yung major axis niya is yung manipis na part kasi hindi mo masyadong mabebend yung ruler na yun towards the other side. Ayun. So doon natin gagamitin itong formula na dito sa handout mo. So that is, so na yun? So let's clear all drawing. So itong formula na to, ito yon. So PEY is equal to pi squared EI over the effective length squared. So yun yung kanina. Pero ang ginamit natin is PCR and trinay natin not only along the Y but along the X. So kaya natin dito laging nakalagay along the Y, the minor axis. Kasi usually ang nagfa-fail dito is the minor. This one. Okay? So that is example number 1. And this is the, yan yung pinadaling version niya. Mas madaling intindihan. So, means buckling strength of the column should be the smaller. So, that is 279.8. The minor axis Y governs. Okay, so ito pa lang, that would be our maximum design na dapat dahil kung hindi, magfe-fail tayo along the minor axis. Next, we have example number 2. Ito yung nasa handout nyo. So we have investigate W250 by 89 section used to carry the loading shown is adequate or not. So using A50 steel, Fy is equal to 345 megapascal. Assume that the column is braced at its ends against sideways, neglect self-weight, assume moment linearly varies from top to bottom, at nabigay lahat ng formula natin. So, ay ng needed natin from the steel manual. So, balikan natin what is the first step. We get the cross-section. We get the slenderness ratio. Pipiliin natin yung mas mataas na slenderness. I-compare natin tong dalawa. Then, we calculate FE. We calculate CR. Then, PN. Okay. So, here, step 1, cross-section classification. So, paano ba tayo nagka-classify ng cross-section? So, meron tayong formula which is BF over 2TF. Tapos, i-check natin kung less than ba or greater than or equal to. So, i-question mark muna natin yan. So, 0.56 times the square root of E over F. Why? Pag ito, if this is greater than, that means non-slender siya. If it is less than, this is a slender member. Okay? So, i-check na natin. We have BF over 2TF. BF here is equal to, ano yung value ng BF natin? Ng TF. Balik tayo dito. Yeah. Ayan. So, let's write that down.
Ma'am, nawala po ata yung...
Nawala yung screen. Okay, let me fix this. There you go. Okay na ulit.
Okay na po.
Ayan. So, let's write that. You have PF here is equal to 257 mm. And yung 2TF given, ay, binigay na nila pala. BF over 2TF given na siya here. BF over 2TF. So, no need to solve. That is 7.41. Nakikita mo ta? Yan.
Apo.
7.41. And then, ang hahanapin na lang natin is 0.56 times the square root of E over Fy. So, this is now 0.56 times the square root of E natin is 200,000. And Fy natin is given as 345 megapascal. So, ano to?
12.04 po.
Ilan?
12.038.
038. Therefore, this is less than our BF over 2TF. That means our wide flange here is non-slender. Okay? So,
Okay.
this is checking for flange pa lang. Mag-check din tayo for web.
Slender po ata.
Ay, teka. BF over TF greater siya. 2TF. 7.41. Wait, let's check your notes. Teka lang, buksan ko lang saglit. Hmm.
Mas malaki po ata, ma'am, yung lumabas dun sa may 0.56.
Yes. Teka, wait, let me just get my notes.
Okay.
So, pag yes, pag mas malaki siya, teka lang. Non-slender. Teka lang. Okay. So, if B over 2TF is less than or equal, non-slender siya. If greater than ang BF over 2TF, slender siya. Or baliktad sa notes. Let's see. Yeah. There we go. Balikan natin. So, yung BF natin, BF over 2TF is equal to 7.41.
Opo, ma'am.
And our 0.56 square root of E over Fy is equal to 13.48. Therefore, BF is over 2TF is less than 0.56 square root of E over Fy. So if ganitos, this is slender, no? Okay. So we continue with checking naman for the web. So this is for our checking for the flange. And then now we're checking for the web. There you go. So pag web naman, we have H over the thickness of the web. And it should be less than or equal to 1.49 times the square root of E over Fy. Okay. So for this, given ba ang ating H over TW? Given din, no? Given siya as 18.7. And this one we could solve. So this is 35.87.
87.
Okay, so again, H over TW is less than 1.49 the square root of E over Fy. Ayan. So this is also slender. So ayan, now that we know kung ano yung classification niya, pwede na tayong mag-move forward to checking the slenderness about the major and minor axis. So ito yung first part. Let's now go to our second part. To check for the slenderness. So to check for the slenderness along the major axis, yung parang ginawa natin kanina, you have your slenderness ratio equal to K, L. So that is your effective length over R. So if it's the slenderness ratio along the major axis, it would now be K Lx over Rx. If it's the slenderness ratio along the minor axis, that would now be K Ly over Ry. So, na given ang ating K and ang ating Rx and Ry. So, loading adequate or not, assume that the column is braced at its ends against sideways. So, pag binilikan natin yung bracings, dito, brace at its ends against sideways. So, ito yung walang horizontal na movement. We have K equal to 1.0. Ayan. And then, what else? To check the slenderness ratio. So here we have K equal to 1.0, Lx and Rx. So yung length natin is 1,000 kasi 10 meters yung given sa atin dito. So this is 10 meters. This would now be our Lx and Ly. Yan, itong 10 meters na to. L is equal to 10 meters. Kunin pa natin yung mga values. You have Rx is equal to 112 millimeters, and you have Ry is equal to 65.3 millimeters. Okay. So, ilagay na natin yan sa ating formulas. This is equal to K 1.0 times the value of L, 10 meters. And let's convert this into millimeters. So times 1,000 divided by Rx, which is 112. So ilan ang slenderness ratio natin along the major axis?
Bali po, 89.286.
286. Okay. And then next, let's try naman sa minor axis. So the K is also 1.0, same length. Convert it to millimeters divided by Ry, 65.3. So ilan to?
Bali po, 153.139.
139. Okay. So this is your slenderness ratio. Ayan. So after nating ma-check yung slenderness ratio, we Step number 3, balik tayo. Check the slenderness ratio about the weak axis and then choose. Basic ko na to. Yan. So we choose the higher slenderness ratio. So if we have 89 versus 153, ang gagamitin natin ay itong 153.39 kasi we choose the higher slenderness ratio. And then after that, pupunta na tayo sa pag-calculate ng elastic critical buckling. So tapos na natin to. Cross-sectional classification. Tapos na natin mag-check ng slenderness. Tapos na tayo mag-ratio. And pinili na natin yung pinakamalaki. Ang next natin is to look for FE. Okay. So, erasing ko na ulit ito. And let's now go to step number 3. Check the elastic buckling of FE. So for the formula FE is simply pi squared E over the slenderness ratio squared. Yun. Ang gagamitin nating slenderness ratio dito is the higher one, yung sinolve natin kanina. So this is simply pi squared times 200,000 over the slenderness ratio na nasolve natin, that is 153.138. Tama ba?
139 po.
139 quantity squared. So, ano yung value ng FE natin?
Bali po, 84.17.
Ayan, 84.17 megapascal. So, this one, di ko muna i-erase. Lagay ko dito sa taas para madali nating matandaan mamaya. Ano pa yung mga kinonsider natin? Okay. So, now that we know FE, let's go to the next step. So, we're done with check the elastic critical buckling. Now we check the flexural critical buckling. Okay. So before we do that, we have two kasi in flexural. We check if your slenderness ratio is less than 4.71 times the square root of E over Fy. Pag chinek natin to, and ayan, so i-check muna natin yan, di pa tayo sure. If your SR is, or your slenderness ratio is less than that, then we could use FCR is equal to 0.658 Fy over Fe times Fy. So, yan, kaya natin i-check. Pero, kung yung slenderness ratio natin ay mas malaki sa 4.71, ang gagamitin natin, FCR is equal to 0.877 Fe. Okay, so let's put this aside. Let's check for 4.71, the square root of E over Fy. So this is equal to 4.71 times the square root of 20 or 200,000 divided by the Fy natin na 345. Ayan. So ilan to?
24.077.
24.077. Okay. So yung slenderness ratio natin na nag-govern is 153. And this is greater than 24.077. So, kaya ang gagamitin natin na formula ay FCR is equal to 0.877 FE. Kaya nauna natin kinalculate yung FE kanina. And since we already know the value of FE, which is 84.17, we just plug that into our formula. So let's put that in. We have FCR is equal to 0.877 FE. So this is equal to 0.877 times 84.17. So makuha na natin yung flexural critical buckling.
Bali po, 73.817.
73.817 megapascal. Ayan. So, from there, i-save ulit natin to. Lagay ko dito sa taas para madali nating matandaan mamaya. So, now that we know the flexural critical buckling, we now go to the next step, which is we compute the nominal strength Pn and Mn. So, let's erase this one. So, ang Pn natin is the FCR, kanina, yung sinolve natin, times AG. Okay? So, is AG given?
Opo.
Okay. Kasi that is a property of steel, no? So, Pn, so nakuha na natin ng FCR, that is 73.817 times AG. Ang AG natin is 11,400. So, what is the value of our Pn?
Bali po, 841,513.8.
513. This is
Point
in
Newton.
Newton. And then we divide it by 1,000 para maging kilonewton siya. That would now be 841.513 kilonewton. Ayan. So again, I will bring this up here para madali nating makita mamaya. So medyo pahaba na ng pahaba ang ating steps, but we're already in step 5. So malapit-lapit na. So this is 841.513 kilonewton. Next naman is i-check natin for compactness. So compactness here is, that is your, this is gamma, I forgot, of the flange and gamma of the web. So that is PF for the flange and delta, no, that's not delta, PW for the web. So ang formula ng compactness is 0.38 times the square root of E over Fy. And for our web, we have 3.76 times the square root of E over Fy. Okay, so PF is equal to
9.149.
9.149. And for our web, ilan yan?
90.53.
90.53. So again, lalagay ko ulit dito sa taas. Delta PF compaction, it is 9.149, and the other one we have for our web, that is 90.53. And drawing ko na lang. Oh no. Okay. And then after this, we also get M and Y. So our nominal moment is equal to Fy Zy. Both of these are given. So Fy natin is 345. Yung Zy natin is, saan yung Zy? 574 times 10 raised to 3. Nasa ilalim lang ng Rx. Okay. And we also have another formula for M and Y, or our nominal moment along the Y. That is also 1.6 Fy S Y. So 1.6 siya times Fy natin is given, that is 345. Sy natin is also given, that is 377. 377 times 10 raised to 3. So lagi ginagamit natin itong dalawa. So pareho natin siyang kukunin, tapos saka natin pipiliin yung mas maliit na value. Okay? So ilan tong una?
Balik po, ma'am, 198 times 10 raised to 6 po.
Times 10 raised to 6. This is in Newton millimeter squared. Newton millimeter. Kasi moment.
Newton.
And this one is?
Bali po, 316.848 times 10 raised to 16.
Millimeter. Okay. So, ang gagawin natin, i-compare natin silang dalawa. And then, pipiliin natin yung mas maliit. So, ang governing natin here would be the smaller value, that is 198 times 10 raised to 6 Newton millimeter, or pag i-convert natin dito sa kilonewton meter, divided by 10 raised to 16. Baka square to.
Bali 198 lang.
In kilonewton. Wait, let's check our So megapascal is Newton per millimeter, and this is millimeter cube. Tama, Newton millimeter. Kilonewton. Kilonewton millimeter ang megapascal. So times 12 pa yan, and then divided by, so gagawin din natin tong kilonewton. So let's convert this na lang para hindi na tayo mahirapan. This is 198 kilonewton millimeter. And then this one, oh, sorry, kilonewton meter. So let's call it dito sa taas. We have M and Y. Yung nag-govern na yung isusulat ko. So this is 198 kilonewton meter. Okay? So dito tayo sa mag-govern na smaller value. Now that we have M and Y, let's also solve for the nominal moment along the X. So that is our M and X. Ito naman, this is equal to Fy times Z X lang. So this is now 345 times 1,200 times 10 raised to 3. So what is the value of M and X?
Bali po, 414.
414.
Yun, sakto po.
Sakto. 414 kilonewton meter. Okay, so I will write this again dito sa taas. That is M and X is equal to 414 kilonewton meter. Ayan. Okay. So again, we are tasked to compute the nominal strength Pn and Mn. Nakuha na natin. So we have the value of Pn here. We have the value of Mny, and we have the value of Mnx. Let's go to our next step. So erase ko na to. And our next step would be to get the lateral torsional buckling. So ito yung pinakita natin kanina na mahabang formula. So we have two formulas there. We have LP, and that is 1.76 times RY times the square root of E over Fy. And we have the LR, and this is now equal to 1.95 times R, yes, times the square root of JC all over SXHO times the square root of 1 plus the square root of 1 plus 6.76 times 0.7 Fy SXHO over E JC quantity squared, and lahat yan under this whole square root, initial square root. Okay. So let's plug in our values. Let's try LP first. So we have 1.76. What is the value of our RY? $65.3 times the square root of E over Fy. So that is 200,000 divided by 345.
Bali po, 2.767 meter.
2.767 meters. Okay, so that is for LP. Now let's go get LR. So this is long, but this is simply yung mga nakuha na nating values from the previous one. So we have LR 1.95 times the square root times RTS muna. So I think this is a given. 73.2 times the square root of JC wait, may nakalimutan ako dito. Meron pa tayo ditong E over 0.7 FY. Yan, times the square root of JC over SXHO. Ayan. So everything else here is now given. So we have E 200,000 over 0.7 times 345. Ayan. And then i-multiply natin yan sa square root ng JC natin. That is yung J na 1030 times 10 raised to 3 mm to the fourth. So given din yan. 10,030 times 10 raised to 3. Pero kinonvert na ata siya into, as is na. And we have times 1.0, that is your CB. So 1.0 na multiplier divided by 1090 is your value of SX. So, kaya natanggal yung times 10 raised to 3 nila dito kasi itong 1030 raised times 10 raised to 3, dinivide din natin ng 1090 times 10 raised to 3. So, nag-cancel lang yung times 10 raised to 3 nilang dalawa. Kaya siya umikse. And then, our HO is also given. That is 242. At is also given nasa ilalim siya ng RTS. So, let's go back here. Mouse, yan. So, ito yung mga given natin. LP. Yan. So, we have 73.2. Ito yung 73.2 natin. RTS dito. You have your 200,000. This is your E. 7,345 is your FY. You have 1030. Ito yung 1030 natin, the value of J. 1090, that is your SX dito. Let's continue. 1090 times 242, that is your HO. So, dito mo siya makikita. This is your HO. And we're not done yet. So, times the square root of 1 plus the square root of 6.76, that is part of the equation, times 0.7 times FY, that is 345, times SX, that is 1090, times HO, yun yung 242. Ayan. Over E, 200,000, times 1030, that is your J, and times C, 1.0, and this whole U square. Ayan. Okay, so mukha siyang marami pero simply this is where they came from. So ito, this is FY. From here, you have J dito. Yung C natin is 1.0. SX natin is here. HO natin dito given din. FYX, HOJC, paulit-ulit na lang siya. So that is where they came from. Everything else is direct substitution. So ano yung value ng LR natin?
Wait lang po.
Okay lang, medyo mahaba rin kasi.
Okay. Wait lang po, ma'am. Hindi nagkasya sa calculate. Ulitin
It's
ko.
okay. Gusto mo, unti-untihin natin para magkasya tayo.
Sige po.
Sige. So, umpisahan natin dun sa pinakaloob. You have 7. Isulat ko na lang. So, this is the internal. You have, wait lang. So, we have LR here is equal to, dulo tayo, 0.7 times 345 times 1090 times 242 divided by 200,000 times 1030 times 1.0 tapos i-square natin to. Ilan yung value?
Wait lang po. Bali po, 0.09.
09. Okay. So this value, i-multiply na natin to dito sa 6.76. So ilan siya?
Bali po, 0.646.
Okay, so that is 0.646. And then meron tayong plus 1. So magiging 1.646. Tapos kunin natin yung square root nito.
Bali po, 1.283.
1.283. Okay, tapos another plus 1, ilan yon?
Bali po,
2.283. And then i-square root ulit natin to. Palapit na tayo sa huling square root.
Bali po, 1.511.
1.511. So tapos na natin itong parteng to. We remove this and hanggang dito sa last. Square root of 1. Okay, next part, let's take this area. You have the square root of 130 times 1 all over 90. 1090 times 42.
Bali po, 0.062.
0.062. So, ayan. You have 0.062. Imu-multiply na natin sa nakuha natin kanina na 1.511 times 200,000 all over 0.7 times 3, 4, 5. So, ilan na to?
Bali po, 78.194.
78.194. Malapit na tayo. So, ito times pa natin to sa yung pinakauna, that is 73.2 RTS. And then, lastly, yung initial multiplier natin na 1.95. So, ilan to?
Bali po, 11.161 meters.
Ayan, ang haba, no? Pero at least we were able to get LP and LR. So let's write that here. We have LP is 2.767 and our LR is 11.161 meters. Okay. So after getting the lateral torsion, we move forward to this area. So tanggalin ko na ulit tong mga to. Balikan natin yung previous slides. Kailangan naman natin kunin itong CB. Ayan. So, to get CB, tingnan natin yung given sa atin na ito, ang ating column. So, pag drawing natin to, this is our column, this is 10 meters. And sa pinakadulo niya, we have MU is equal to 90 kilonewton meters. So, uniformly varying yung load natin dito. So, this is 90. And then, dito sa ilalim niya, 68. Ayan. And, ganyan yung itsura ng ating uniformly varying load. Okay. So, let's go to the principle of CB or, yes. So, you have CV is equal to 12.5 maximum. So, yung 90 yon over 2.5 max times 3 MA. MA is at the quarter point. MB is at the center line. And MC is at the third quarter point. So, pag drawing natin to, so, meron tayong 4 na hati. So, this is your, yan. So, unang quarter, meron kang MA sa 1/3. Meron kang B sa 1/2. At meron kang C sa 3/4. Okay. So, paano natin makukuha yan? Let's project this. So, this is 68. Diretso yan. So, ang kailangan natin is the height here, or let's say HA, the height at A, the height at B, and the height at C. Ayan. Pero if we draw that like something else, magmumukha siyang similar triangle. Ayan. Wherein, kung 68 ito, at 90 ito, ano ang height na to? Di ba that is simply 68 or
Minus
90 minus 68. So, ilan yung value?
22.
22.
22 po.
Okay. So, pag kinuha natin to, and if our length here is yan. So, I think we don't have to consider the length. Kailangan lang natin kunin is the height. So, if nahati to into 4, this is simply, ayan. So, lagyan ko lang ng mga linya. We have, this is at 3/4, this is at 1/2, and this is at 1/4. So, yung multiply lang natin, you have 22 times 3/4, 22 times 1/2, and 22 times 1/3. Makukuha na natin yung value ng HA, HP, and HC. So, ilan to? So, let's look for HA is equal to 22 times 3 all over 4. Ito yung next sa pinakamalaki.
16.5 po.
16.5. We have HB is equal to 22 kalahati times 1/2.
11.5.
And we have HC equal to 22 times 1/3, 1/4. Yes, 1/3.
Bali, 7.33 po.
7.33. Pero hindi ito yung final values nila kasi at the bottom, hindi siya 0, 68. So to get their values, i-add natin tong initial na hindi natin
68.
kinonsider na 68. Yan. So ano yung value natin at HA?
Bali po, 84.5 po.
84.5. The next one,
79 po.
and lastly, we have
75.33 po.
0.33. And this is now your MA, MB, and MC by just looking at our triangle. So I will erase this. And let's now go to our formula. We have CB is equal to 12.5 M max. Okay, all over 2.5 M max plus 3 MA plus 4 MB plus 3 MC. Okay, we all know the values of MA, MB, and MC. So ang gagawin lang natin is to plot them. We have 12.5. Our maximum moment is given dito as 90 kilonewton meter. And then i-divide natin to by 2.5 M max, that is times 90, plus 3 MA, that is 3 times 84.5, plus 4 MB, so 4 times 79, times 3 MC, so times 3 times 79, 75.33. And from there, we will get the value of CB. So ano yung CB natin?
Bali po, 1.102.
1.102. Okay. So again, let's put that here sa taas. CB is equal to 1.102. Ayan. Okay. So dahil alam na natin yung value ng CB, makukuha na natin yung moment of capacity. So let me erase this one. And let's go to our MN na page. So this is your MN is equal to CB times MP minus MP minus MR times LB over L minus LP over LR minus LP. Dapat less than or equal siya sa MP. And we also have this other formula, CB. Yan. Okay, so let's go back to our problem. Flexural, tapos na, nominal, torsional buckling, compute for CV, compute for moment capacity. Ayan. So let's go back here. Let's write down our formulas. We have MP is equal to Fy Zx. And that is Fy 345. Zx is this one. So 1220 times 10 raised to 3. And then let's convert that to kilonewton meter later. So what's the value of MP?
Uh, 420.9
Kilonewton meter. Okay. And then let's solve for MN. So the value kanina, MN now is equal to CB times MP minus MP minus 0.7 Fy Sx. Yan. Times LB minus LP over LR minus LP. And that should be less than or equal to MP natin. So let's solve for M and X. CB natin here is 1.102. MP natin is 420.9. Ito yung kakasolve lang natin. Minus 420.9 minus 0.7 times Fy, that is Fy 345. Sx dito is 1090 or 1.090 pag ginawa nating meter. Ayan. Times LB natin is 10. That is the length of the beam. Minus yung LP natin, that is 2 point, itong sinolve natin dito. If you remember, this is your value of LP, 2.767. Ayan. So, minus 2.767 divided by, again, your LB, the length of the beam, that is 10. LR, yung sinolve natin, 11.161. So, this is also your LR. So, yun. And then, minus the value of LP, which is 2.767. So, and we multiply everything. What is the value of MN?
Bali po ma'am, 249.75.
249.75. Okay? So, pag chinek natin, dito siya nanggagaling. So, CB natin. So, CB came from the value of CV 1.12. MP is 420. Itong sinolve natin na to. LB is the length of the beam, 10. LP is yung sinolve natin kanina. LR also, yung 11.161 na mahaba. And yun lahat lang yung magagamit natin for MN. Ayan, so may value na tayo ng MN. I-check natin, is it less than or equal to MP? So, is MN less than or equal to MP? And the answer there is yes, because 249.75 is less than 420.9. Okay? So, after that, patapos na tayo. We have your last step, which is step 9. Example. Ito nga. So, step 9, 7, 8. And check for combined actual load. So, meron na tayo. Yung una nating tinignan, which is PR over PC is greater than or equal to 2. Ito yung gagamitin natin. Or if PR over PC is less than 0.2, ito naman sa ilalim na formula ang gagamitin natin. So, first, let's check. PR natin is given. Check natin dito. Ayan. So, let's go to our formula again or our initial given. Itong my picture. So, PU, yun yung PR natin. So, PR, that is the applied P, that is 200 kilonewton dito sa drawing. And then we have PC. Ito sinosolve natin as 0.9, the FCR, the critical F, times AG. So, 0.9 yan. Yung FCR, that is 73. Or this is simply equal to PN, 841.513. PR is equal to PN, 841.513. Nakuha na natin din dito. And then, ano pa yung kailangan natin? Let's check. So, PR over PC, check natin if less than or equal to 2 or greater than. So, ilan to?
Bali po 0.238.
238. Ibig sabihin, greater siya ng 0.2. Ang gagamitin nating formula is yan, this one kasi mas malaki siya. If PR over PC is greater than 2, then we use PR over PC plus 8 over 9 times MRX over MCX plus MRY over MCY. Ayan. And that is supposed to be less than or equal to 1.0 kasi pag sumobra siya, that means it is not safe. So let's go back to our drawing para makita natin yung mga given natin. Ayan. So we have PR over PC. Na-solve natin yan. That's 0.238. Ito, yung tinignan natin kanina. Wait. This is PC natin is 0. Nakalimutan natin yung multiplier nito. P 0.9 dapat yan. 0.9 PN. So, times 841, ilan to?
Bali po 84. 757.362 po.
757.360. 363?
362 po.
362. Okay, so this also changes. 757.362. What is the value of PR over PC?
0.264.
0.264, which is still bigger than 0.2. So, yun pa rin yung gagamitin natin. Okay, so plus 8 over 9. Okay, so yung MRX natin, that is your maximum moment. Ito yun, MU. So, that is 90 kilonewton over the MCX. So, lagay ulit natin to dito. We have MCX is equal to 0.9 of your MNX. Yung MNX na-solve natin kanina. So, this is your MNX, the 414. Wait. MNX. 414 kilonewton. MNX. So this one. 0.9 times 414 kilonewton meter. So this is ilan?
372.6 po.
372.6. And let's also solve for your MCY. This is equal to 0.9 FYZY. So this is, or simply 0.9 MNY kasi na-solve na pala natin. This is your MNY dito na sa taas. Ayan, so we have 0.9 times 198.
Bali po 178.2.
178.2. Okay, so direct na natin sa ating formula. We have PR over PC, that's 0.264 times 8 over 9 times MRX, that is your maximum moment along the x-axis, kaya tayo kumamit ng 90, over MCX, that is 372.6. Ayan. Plus 30, that is MRY, which is your maximum along the minor axis. Dito yon 30 kilonewton, dyan siya nakuha. So that is 30 divided by MCY, 178.2. There you go. And ilan to?
Bali po 0.628 po.
628. And that is our final answer for checking the axial and bending, and it's less than 1.0, therefore it is safe. Okay?
Okay po.
Kaya pang isa pa?
Okay po. Okay lang po.
Sige, sige. So I'll erase all of this. Let's go now to our next example. Yan. So, ganun lang ginawa natin. Step 1, the cross-section classification. Step 2, check the slenderness ratio. Step 3, elastic critical buckling, the FE. Step 4, we get FCR. Step 5, we compute for the nominal strength, the N moment, so force and moment. Step 6, we have the lateral torsional buckling, LR. Step 7, we look for CV. Step 8, we look for the moment capacity. Step is, we look for the flexure and compression. And lastly, we put that all in to check for the actual load. Okay, so let's go to our next question we have here. Calculate the available strength of an A36 steel wherein Fy is 36 KSI, the W8 by 8 by 40. Yung column natin is 25 feet long and is pinned on the top and bottom. So pag pin sa top and bottom, balikan natin, that is 1 and 1. So ito siya. Pin top, pin bottom, K is equal to 1. Recommended is also equal to 1. So example number 3. Yan. And what else? Strong axis is an brace, the length of 25 feet. And the weak axis is the torsional unbraced length of 12.5 feet. Given na lahat, we have your height, BF, TF, W, RA, IX, IY, IX, IY. So balik-balikan na lang natin tong page na later when we're going to put everything down. Okay, so let's begin. Number 1, we check for the cross-sectional classification. Wait, let me just look for my notes. Ayan. So again, for cross-sectional, we get B over 2TF. 2TW, and this is equal to, ano yung B natin kanina? The value of B is 8.07, ito. Over 2 times yung TW natin is 2T, 7 point. Sorry, so this is 2TF. TF natin is 2 times 0.56. So this is for the lunge. Okay. So, ilan to?
Ano po, ma'am?
Hello?
Hello po.
Yun, medyo
Hindi po,
nagkaka-pro.
ma'am. 7.205 po.
7.205. Let's check naman if it's less than, equal, or greater than 0.56 times the square root of E over Fy. Our E is 29,000 since we're using KSI. So this is 0.56 times the square root of 29,000 over the Fy of a 36 still, which means it's 36 KSI. So over 36. Ilan to?
Bali po 15.89.
15.89. Okay. So since BF is over 2TF is less than R 0.56 square root of E over Fy. Ayan. Then this is slender. Ayan. And then let's now check for the web. So pag web naman, we have H over TW. Yung H natin is height of our web depth, that is 8.25 over the thickness of the web, that is 0.36.
Bali po 22.917.
917. And let's check that against 1.49, the square root of E over Fy. Ayan, so 1.49 times 29,000 over 36.
Bali po 42.29.
0.29. So again, it is less. So this is H over TW is less than 1.49 square root of E over Fy. Therefore, we will consider this as slender. Okay, so let's move on. Step 1, cross-section classification. We already know na we will consider it as slender. Next, we check the slenderness ratio. So this is step 2. Oh, wait, let's check for the slenderness ratio first before we go to the elastic. So SR is equal to the KLX over RX. This is for your major axis. And you have your slenderness ratio along the minor axis. That would be KLY over RY. Ayan. So, balikan natin yung given kanina. I will erase this. So, K natin, since pinned at top and bottom, that is 1.0 for X and also 1.0 for Y. LX natin, that is 25 feet. And then we multiply that to 12 inches para maging inches siya. For LY, ito yung minor axis, nakalagay dito is 12.5 feet naman siya. And then we multiply that to 12 para maging inches siya. And this is divided by RX. RX here is RX. What's the value of RX? Check natin to. So if we search for the W8 by 8 by 40, we will get Rx equal to 3.53, and we will also get Ry equal to 2.04. So this one we get from the steel manual. So if ever hindi siya given, search for it. If you're not allowed to search for it, you ask your instructor in case nakalimutan niyang ilagay. Okay? So let's go
Okay po.
back. So Rx 3.53. Ry divided by 2.04. So, ilan yung slenderness ratio natin along the major and minor axis?
Bali po, 84.986 po.
84.986. And next we have
Bali po, 73.529.
ayan. So, that is our slenderness ratio. So, let's go to our steps. We have step 1, cross-section classification. Alam na natin na slender siya. Step 2 is we look for the elastic critical buckling. And to solve for that, that is simply Fe is equal to pi squared times E, the value of E, divided by the slenderness ratio na nag-govern squared. So this is simply pi squared times 29,000 divided by, alin yung nag-govern dito, yung 84 or yung 73?
Yung 84 po.
Yes. So times 84, divided by 84.986 quantity squared. So what is the value of Fe?
39.628 po.
This is KSI. Okay, now that we have Fe, let us solve for the next step. We have FCR. So again, we check the limit. Para alam natin kung ang gagamitin natin ay yung first equation or second equation. So let's check 4.71 times the square root of E over Fy. So this is 4.71 times the square root of E natin is 29,000 divided by Fy, which is 36.
Bali po, 133.681.
133.681. Okay. So, pag chinek natin, compare natin siya sa governing slenderness ratio, yung limit natin is still great. Wait, let's go back. Yeah. So, it's greater than 84.986. So, pag ganyan, ang gagamitin nating formula, so balik tayo sa formulas natin. For FR, this is FCR. Ito. Zero 0.658. Cross-sectional buckling FCR. Okay. So this is equal to FCR equal to 0.658 times Q Fy over Fe times Q Fy. Okay? And yung Q natin is yung K, which is also equal to 1.0. So pwede na natin siyang i-disregard since it's also equal to 1. So this is now 0.658. Fy natin is given at 36. Fe natin, na-solve natin yan as 39.628 divide, and then i-multiply again to Fy. So that is now times 36. So what is the value of FCR?
21.535 po.
21 point?
535.
535. Okay. And let's continue. So we now have the value of FCR. Wait lang, palitan ko ng kulay para mas madali nating ma-distinguish later when we check the steps. Okay. Next, step 5, compute the nominal strength Pn and Mx. So let's remember the formula for Pn. This is FCR times Ag. Na-solve natin yung FCR dito as 21.535. Ag natin is 11.7. Wait, let's check our given. Ag 11.7 inches dito. So that's what we're going to use. What is the value of Pn?
251.954.
954. Okay. And then next, let's look for the LRFD na siya. Since ang given sa atin is, check natin, calculate the variable strength, column is at the top and bottom. And since hindi siya fixed hinge, and ang nakalagay lang dito is spin, wala tayong moment. Okay? So, itong column kasi natin is pinned at both edges. Ayan. So, pin dito, pin dito. So, kung pin, wala tayong moment. Okay? So, walang moment. Therefore, we don't have to calculate MNX. Gets?
Okay po.
Oo. Pero pag katulad ng first example na nagbigay siya ng moment sa magkabilang dulo, that means fix siya. You solve for MNX. Pero since ganito, pwede na tayong dumiretso. So, we have for LRFD, this is equal to Phi times Pn, wherein P is equal to 0.9 times yung Pn, yung na-solve natin kanina, that is 251.954.
Bali po 226.759.
226.759 kips. And then let's try for ASD. Okay, so that is simply Pn over the omega C. How do I write that here? And this is equal to 251.954 divided by 1.67. So this one is the value of this one, which is our multiplier, para maging safe lang siya for consideration of ASD. So ano to?
Bali po 150.871 po.
150.871 kips. Okay. And yan na yung hinahanap. So, ang tinatanong kasi, calculate the available strength of ASTM steel. And ang available strength niya, if we use the LRFT, is 226.759. And if we use ASD, which is more reserved, or mas malalaki yung divisors and considerations, this is 150.871. So you as a designer can use both kasi pareho naman silang provided by the code. Here in the Philippines, we use LRFD madalas. So this is what we use with the National Structural Code. So ito lang talaga siya. Hindi na siya kailangan gawing komplikado. The first thing we do is to check if it's slender or non-slender. If it's slender, we move forward to checking for the slenderness ratio. And then, ang kunin natin yung mas malaki. Pag nakuha na natin to, solve natin yung FE. Yung FE pi squared E over the slenderness ratio lang. Pag nakuha natin yung FE, check na natin kung anong value ng FCR ang gagamitin natin. So, check natin if it's greater than SR ito, if not, yung other formula, and then direct substitution na tayo sa FCR. Pag nakuha na natin yung FCR, makukuha na natin yung nominal strength. Nominal strength is just FCR times the AG, which is the area given na makukuha natin sa table. And then next, pag nakuha na natin yung PN and no moment is given, gamitin na natin yung LRFD and ASD, wherein this is only P times PN, which is 0.9 times the nominal shear. And for ASD, that is nominal shear divided by omega C. Pero pag given sa atin is my moment, or meron tayong fix, ang gagamitin natin yung hahanapin natin yung CB. After nating mahanap yung CV, hanapin natin yung MNX, MNY. And then after that, kunin natin tong flexure compression. And lastly, we check for the combined action load. So, as long as we know the steps isa-isa, mas madali na natin siyang sundan. Okay? So, I think this is our final example. Determine the local buckling and slenderness for a W14 by 74 section given K, KY, LX, LY, and RX, RY. Okay? So, again, let's check for the slenderness ratio. So, we have SR is equal to KL over R. We check SRX. That's KXL over Rx. And we have SRY, that is KY LY over RY. So let's check this vote. KX natin is 1.0. LX natin, 240 inches. And RX natin is 6.04. For Y naman, we have K is also 1.0. LY is also 240 and RY is 2.48. So what is the value for our slenderness ratio?
Bali po, 39.735 po.
And the other one?
96.774 po.
Okay. So ano yung gagamitin natin?
Yung higher po, yung 96.7.
This one. Okay. Ba't lahat ng change? Okay. So let's use SR now. Equal to 96.774. After that, we check our limit. So, i-compare natin to sa 4.71 square root of E over Fy. Ayan. So, yung katulad ng ginawa natin kanina, that's simply 4.71 times the square root of E natin is 29,000 since naka-KSI tayo, divided by A36 to. So, this is 36 KSI. So, ilan to?
Bali po, 133.681.
681. And this is still greater than our SR or slenderness ratio. Ibig sabihin, ulitin natin yung ginamit nating formula kanina for FCR. So, let's first get our FE. Pagkatapos natin kunin to. FE is simply pi squared times E all over SR squared. So this is pi squared times E is 29,000 divided by our governing slenderness ratio, that is the bigger one, 96.774 squared. So ano yung value nito?
$30.562.
30.562. And after we have FE, pwede na tayong dumiretso sa FCR or yung critical nating F. And since it's less than SR, ang gagamitin ulit natin na formula is 0.658 times Fy over Fe times Fy. So this is now 0.658. Fy natin is A36 still, that's 36 KSI divided by Fe, we solve that as 30.562 times Fy na 36. So, makuha kaagad natin yung FCR.
Bali po, 27.90 po.
27.90. And once we get FCR, makukuha na agad natin yung nominal. So after nyan, we have PN next. PN is AG FCR. AG natin given ba? Hindi. Pero if you search for W14 by 74, you will have AG for W14 by 74 as equal to 21.8 square inch. Okay, so let's plug that into our formula. We have 21.8 times the value of FCR, 27.9. Makuha kagad natin yung PN. What is the value of PN?
Balik po, 608.
68.
6, ay, wait lang po. 608 po.
Oh, 608.22.
0.22 po.
Ayan. So this is in kips. And then last, we look for the LRFD and ASD. So sometimes we have LRFD equal to 0.85 PN or 0.9 PN. Depende sa ginagamit nyo na manual. Kasi to puro ano na lang to, kumbaga pang factor natin. So for your school, do you use 0.85 or 0.9?
0.9 po.
0.9. Okay. So let's use 0.9 PN. So this is simply 0.9 times 608.22. So ano to?
547.
20,
547.398.
398. And then if we check for ASD, that is PN over gamma C. Tinatamad ako i-drawing yung ano eh, gamma. So this is 608.22 divided by 1.67 is your gamma, no?
Opo.
Yeah.
$364.204.
204. Okay. And these are your design elements na. So, ito na yung kailangan mo if you're going to use. Ibig sabihin, if you're going to make your building, say, ito yung building mo, tapos naglagay ka ng mga column dyan at ang ginamit mong column dito is the W 14.74 and you're using ASD, ibig sabihin, hindi ka na pwedeng maglagay ng load greater than 364 on each column kasi bibigay na sila. And if you're using LRFD, that is 547. And if you're wondering bakit pareho silang safe if we use 547 safe siya, if we use 364 safe siya, that is because yung LRFD natin mas mataas siya kasi it focuses on economy and safety. So ang gusto nila is ma-maximize mo yung columns and other items mo while having it safe. While yung ASD natin is focus on safety over economy. So pag makikita mo, most of the ASD designs are bigger, mas makapal, mas maraming bakal. It's because it's more conservative than LRFD. Okay, pero both are safe because we already get our maximum nominal as long as we don't pass 608 kips, our design is safe. Okay? So,
Okay.
medyo nakatulong naman ba ito?
Gets ka naman.
Okay. So, ni-request nila tita and mama na you have practice exercises. So, naglagay ako dito. And then, you can solve it if you have time. Para in preparation for your exam, or if you want something else to review, that's also okay. Pero if you want to solve this and then you want the answers then siguro by tonight, ganun, I can send you the PDF where this has its own solution na. So i-check mo muna on your own and then I could send kung paano yung sagot and then i-compare mo later if nakuha mo siya ng tama. Okay?
Okay po.
So I will send this to you and this ends our session. So thank you so much. I will see you on Tuesday.
Thank you po, ma'am.
Okay, thank you.